Dear teachers, welcome to the assessment and evaluation lecture. We are looking at the statistical part of this unit. So far, we have covered the mean, mode, median, range, frequency distribution table, all these concepts. I have sent you some practice problems. I have also sent you some YouTube videos as well so that these concepts are clear with you. We have also looked at standard deviation. We have seen how to find the square roots. So we have tried and understood the statistical concepts which are there in this unit. We will also look at these concepts once we start with the synchronous lectures, which will start very soon. Right now we will look at graphs, why graphs are important and how we should be plotting them. So what we are going to look at is that we are going to look at two types of graphs. We are going to look at histogram and we are going to look at frequency polygon. Both these graphs are very easy to plot and very easy to understand. Okay, so let us see why graphical representation is important, or why do we need graphical representation. Now, when we speak about statistics, we are talking mostly about numbers, and looking at the numbers, especially if you are a teacher and if you have to look at the marks of your entire class, it may become very tiring for you. So rather than looking at the marks of the entire class in numerical form, you can always look at these marks in the form of graphs, because graphs can be more attractive and they can be more appealing to the eyes. You can plot these graphs on graph papers or in your notebooks, or for that matter you can also use the computers. Now, when statistical data is presented, it can be presented in an attractive form, or a form in which can be appealing to the eyes when you use graphs. You can add colors to graphs as well so that they look more attractive. There are different types of graphs. There are, apart from histogram and of course frequency polygon, there are also bar graphs. There are circle graphs, which are also called pie charts. So you have come across these graphs in various forms. You have come across these graphs. Uh, so now as teachers, you might want to use them as well to make your data, uh, to make the presentation of your data more appealing. Okay, so graphs can help you to make your presentation more appealing and more attractive. And anyway, whenever you use graphs, these are pictures, so a picture carries a lot of communication power. So a presentation which will have graphs will communicate more information that normally only the numbers may not do. So a mere glimpse of the graphs may enable the viewer to have an immediate and meaningful grasp of a large amount of data. So if you're talking about 60 students, 70 students, then of course the data can be put in graph and it can be shown. So visual presentation of this numerical data arouses interest and has a lasting effect, and it translates numerical data into understandable form for interpretation, and comparison of frequency distributions is easier. So visual presentation of this data of course will arouse more interest among the viewers and those who are listening to you or watching your presentation, and it will have a lasting effect or impact on them. And graphs normally translate the numerical data into an understandable form and it becomes easier for you to interpret the information from that. Then it also helps in analyzing the numerical data. It helps to understand the data of frequency distribution, and it permits easy visualization. So in other words, graph helps you to look at data in pictorial form, and it becomes more appealing to the eyes as well. Okay, and it has a lot of information which can be put on one sheet of paper. So let us understand what is a histogram. We will look at a histogram with an example as well. A histogram is essentially a bar graph of a grouped frequency distribution. Uh, the actual class limits plotted on the x-axis represents the width of various bars, and respective frequencies of these class intervals represent the height of these bars. So we will see what all this means when we look at the frequency distribution table. This is a table which has marks of your students and the number of students. So there are 10 students who have scored marks between 30 and 36. There are 20 students who have scored marks between 36 and 42. 15 students have scored marks between 42 and 48. 35 have scored marks between 48 and 54, and 20 have scored marks between 54 and 60. So this becomes your frequency, the number of students, and the marks are plotted as class intervals. So if you see, these are groups, that is, anyone who scores marks between 30 and 36 will come in this group. Those who are scoring marks between 36 and 42 will come in this group. Those scoring marks between 42 and 48 will come in this group. So this way, these are groups, and that is the reason why it is called grouped frequency distribution, because these are groups. Okay, and now let us see what are the other things that we need to understand from this. Okay, so we have understood what is the group frequency distribution. Here there are groups, that is why it is called a group frequency distribution table. Now let us see how the graph looks. This is how your histogram looks like. These are the bars which you see. This is your x-axis. The horizontal axis is called your x-axis, and the vertical axis is called your y-axis. So y is given over here, x is given over here, and the point of intersection of the x-axis and y-axis is considered as the origin. So here you have 0 to start with, and on the y-axis you have plotted the number of students, that is the frequency. So the difference between two consecutive frequencies is the same. So 0 to 5, 5 to 10, 10 to 15, 15 to 20. So the difference between two consecutive frequencies is the same. So 5 minus 0 is 5, 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15 is 5. So that has to be constant, and the class intervals or the marks are plotted on the x-axis. So here 30, 36, 42, 48, 54, 60. Again, the distance between, or the difference between two consecutive values is the same. So 36 minus 30 is 6, 42 minus 36 is 6, 48 minus 42 is 6, 54 minus 48 is 6, 60 minus 54 is 6. Okay, so now how many students have scored marks between 30 and 36? So there are 10 students. So here you consider the frequency as 10. So the height of the bar which you are going to draw will be 10. So from this x-axis, your line segment will go up to 10, and it should be a vertical line segment. And then from 36, because the class interval is from 30 to 36. So another line segment from 36 you need to draw vertically up to 10, and then join these 2 points. So that becomes one bar of yours. Similarly, you will do the bars for the subsequent class intervals. Now, if you see, these bars are attached to each other, and that is why it is called a histogram. In case of another type of graph which is called a bar graph, these bars are not attached to each other. So here in histogram, these bars are attached to each other, and this is how you plot this graph. This the paper which you see behind this graph, which is in the background, is called a graph paper. All of you have seen what is a graph paper because you had to plot graphs when you up at least till your 10th standard, maybe in your 8th or 9th standard, and 10th as well. Okay, so that is about a histogram. Now we will see what is a frequency polygon. A frequency polygon is a line graph for the graphical representation of a frequency distribution. So it is, instead of a bar graph, this is just a line graph. So now this line graph can be drawn using a histogram as well. So let us see how to do it. This is an example. These are the marks and these are the number of students. So marks which are 10 to 20, there are two students who have scored marks between 10 and 20. 8 have scored between 20 and 30, 15 have scored between 30 and 40, 6 have scored between 40 and 50, 5 between 50 and 60, and 2 between 60 and 70. So let us see how to draw this frequency polygon. So if you want, you can plot a bar graph, a histogram first, the way we have plotted it, and then you have to consider the midpoints of each of these bars. So from 10 to 20, so what is the midpoint of between of 10 to 20, that class interval? So it is 15. So you mark the midpoint of this class interval at the top of the bar. So here it is 15, here it is for the next class interval 20 to 30 it is 25. Similarly over here it is 35, 45, 55 and 65. And then you can, of course, these bars have to be drawn according to the frequencies. That means when you say 10 to 20, there are two students, so the height of the bar will be 2 units over here, and all the other criteria you need to look at. That means the difference between two consecutive frequencies has to be the same. So 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. And similarly with this, 20 minus 10 is 10, 30 minus 20 is 10, 40 minus 30 is 10. Okay, so after doing the histogram, you can just join the midpoints of each of these bars. Okay, and since you have the x-axis uh, from where you have to start, you will go back to the x-axis, or the line should start from the x-axis. So you will go to the midpoint of the preceding class interval. So the preceding class interval for 10 to 20 is 0 to 10. So the midpoint of that is 5. So you will start your line segment from 5, it will go to 15, and then it goes on till you reach the last class interval, that is 60 to 70. Okay, now from here again the line has to end, or the frequency polygon has to end at the x-axis. So you consider the midpoint of the succeeding class interval, that is 70 to 80. The midpoint of that is 75. So you from 65 you join the line segment at 75, and this is how your frequency polygon looks like. uh, Actually there is no need for you to have these uh, the histogram along with that, so you can just rub out or erase the histogram, or you can let it be like this. So without a histogram, how will the frequency polygon look? It will look like this. So this is not the same example though, it is a different example, but without a histogram, a frequency polygon looks like this. Okay. So here frequency is given as number of students. Class mark, that is the midpoint of the class interval, is considered as pocket expenses in rupees. And scale says along x-axis 1 centimeter is equal to rupees 5, and along y-axis 1 centimeter is equal to 5 students. Okay, so you have plotted these midpoints of each class interval and you just join them, and since the preceding class interval for 0 to 5 is 0 to negative 5, your line segment your joins the x-axis at negative 2.5. And similarly over here, this is the succeeding class interval of the last class interval which has to be considered. Okay, so this is how the frequency polygon looks like. So let us try and understand what are the differences between histogram and frequency polygon. So histogram is a bar graph. It is pretty evident from what we have seen, and frequency polygon is a line graph. So when you look at the frequency polygon, this is a frequency polygon, the line graph which you have drawn, and not the histogram. Here this is just for reference sake that you have considered the histogram, but otherwise this is how the frequency polygon looks like. The frequency polygon is more useful in comparing two or more frequency distributions because it becomes easier to plot the line graph. If you had to plot another frequency distribution table, it becomes easier to plot it over here on the same line graph or on the same frequency polygon rather than having it rather than having two histograms at the same time. It becomes difficult. Okay. The frequency polygon can be superimposed. That means you can have one frequency polygon on the other. So this is how it can be. You can superimpose the frequency polygon on the histogram. Here you superimpose the frequency polygon on the histogram. Similarly, you can have another frequency polygon over here. So it can be superimposed. Then histogram gives a very clear and accurate picture of the relative proportion of the frequency from interval to interval. That means you get a clear and accurate understanding of what are the marks. Let us look at the histogram. So you get an understanding, a clear and accurate understanding about the marks. So here you can make out that between 30 and 36, between these marks only 10 students are there. Between 36 and 42 there are 20 students. So you get a clear understanding of the information. In frequency polygon, it is easy to know the trends of the distribution. So we are unable to do so in histogram. For instance, over here you will know that in case suddenly, okay, according to this frequency polygon, the trend is upwards, and suddenly it starts dipping over here. Okay, suddenly it may go up over here again. So it becomes easier to understand the trends over here, whereas it is a bit difficult with the histograms. Okay, so we will stop over here right now. We will take up some more examples of this when we have the synchronous lectures very soon. So thank you, dear teachers, for your time and patience. You may go for your next lecture. Thank you.